We are talking about the glycogen storage disease. What is the glycogen storage disease? Before talking the glycogen storage disease, we must know that what is glycogen and where it is stored. Glycogen is a polymer of glucose. The various glucose molecule bind together to form glycogen. The glucose molecule bind together and form glycogen. This glycogen is the source of energy for the next time. When there is extra and many glucose molecule, when there is many glucose molecule and there is no need of molecule, these glucose molecules, the glucose molecules are greater than the needs of the body. So this glucose molecule will convert into a polymer of long chain of glucose molecules will form. This is called glycogen. This is a glycogen, and this glycogen stored in the liver. This glycogen stored in the liver and skeletal muscle. When the body glucose levels drop, so this glycogen molecules again convert into glucose. This again convert into glucose molecules and maintain the blood glucose level. This maintains the blood glucose level. So they are interchangeable. They can convert into long polymer called glycogen. And in the case of the needs of the body, when the glucose level of the blood glucose level lowers, they again convert from the glycogen state into the glucose state, and this glucose used by body. This body use this glucose molecule. So when there is the need of the liver, by the help of different enzymes, break down this glycogen molecule back into glucose, and this glucose goes to the bloodstream, and also go to the skeletal muscles during exercise. They go into the skeletal muscles for the muscular activity to produce the energy called ATP. This glucose are used for the ATP formation. So the glycogen, what is the glycogen storage disease? Glycogen storage disease is a hereditary disorder. There is deficiency of enzymes that involve in the glycogen storage or breakdown. Glycogen storage disease is the hereditary enzyme deficiency in which there may be that enzyme deficiency that involved in the glycogen synthesis, or may be due to that enzyme deficiency that involved in the glucose synthesis, that is breakdown of glycogen. They may be either involve the glycogen chain formation, or they may be involved the glucose synthesis, that is glycogen breakdown. So what is the glycogen storage disease? Glycogen storage disease is a hereditary disorder in which there is enzyme deficiency that involve in the glycogen synthesis to synthesize the glycogen, or that enzyme deficiency that involve the breakdown of the glycogen to convert into the glucose molecules. There are two forms of the glycogen storage disease. Number first is the hepatic form, and second is the myopathic form. Number first is the hepatic form. In the hepatic form, there is deficiency of the enzyme in the liver. Enzyme deficiency in the liver occur, and the glycogen cannot be synthesized. Glycogen cannot be synthesized, and due to the unavailability of the glycogen molecule in the liver, because the glycogen cannot synthesize, there is the enzyme deficiency. So the blood level of glucose lowers. So the blood glucose becomes lower. This is called hypoglycemia. Hypoglycemia may occur due to there is unavailability of the glycogen molecule in the liver, because there is no enzyme to convert the glucose into the glycogen. The example of the enzyme is glucose 6-phosphatase. Glucose 6-phosphatase. If there is the deficiency of the glucose 6-phosphatase, so the liver cannot synthesize the glycogen, and there is no conversion of the glycogen into the blood glucose. There is no conversion of the glycogen into the glucose because the enzyme is absent, because there is no enzyme, and this blood glucose level may lowers and cause hypoglycemia. The enzyme example of the hepatic form of the glycogen storage disease is glucose 6-phosphatase. If the mutation in the genes occur that synthesize the glucose 6-phosphatase, as a result of glucose 6-phosphatase cannot be synthesized, and when this cannot be synthesized, the liver cannot convert the glycogen into glucose, and the blood glucose level lowers and cause hypoglycemia. Number second, the clinical features of this disease, hepatic form of glycogen storage disease, is hepatic enlargement and hypoglycemia. Hypoglycemia due to unavailability of the glycogen molecule to convert back into glucose, and hepatic enlargement. The patient have large hepatic. The patient have large liver. That is hepatic enlargement. Now we will discuss about the myopathic form. Myopathic form. In the myopathic form, we know that the skeletal muscles are also used of glycogen as a source of energy during the physical activity to produce ATP. The skeletal muscle use glycogen. The glycogen are stored in the skeletal muscle. Also, they use this glycogen and convert this glycogen into glucose, and this glucose then used for the ATP formation is a source of energy. When the patient start the physical activity and there is the enzyme deficiency of either the glycogen synthesis or either the glycogen breakdown, so the ATP level is not available. This ATP level is not available. If no enzyme, no conversion of glycogen into glucose, and no ATP available, so the glycogen accumulates. When there is the deficiency in the breakdown of the glycogen, so glycogen accumulates. And when there is deficiency in the conversion of glucose into the glycogen, in this state glucose accumulates. And when there is deficiency of glycogen breakdown, so the glycogen accumulates in the muscles, and they cause the muscular weakness, impaired energy production. They cause the muscular weakness, and impaired no ATP can be formed for the physical activity of the skeletal muscle. Example of the enzyme is phosphorylase. Example of enzyme is phosphorylase. If there is mutation in the genes or that synthesize the phosphorylase, there will be deficiency of the phosphorylase, and abnormal phosphorylase or deficiency of the phosphorylase, or absent the activity of the phosphorylase, and the glycogen cannot be converted into the glucose in the skeletal muscle and the ATP level depletes. The ATP level decreases and this glycogen only accumulates in the skeletal muscles and they cause the muscular weakness and decreases of ATP. The example of this enzyme is phosphorylase. Clinically, the myopathic form of the glycogen storage disease, there is muscle cramps. There is muscular cramps. Decrease the lactate level in the blood after exercise. So the lactate level decrease the lactate level are decreases after exercise. And when this lactate level decreases after exercise and the blood lactate level will be low. Blood lactate level will be low in these cases of the